Hello everyone. Our term project topic is algorithm to acceleration regarding expression in deep package inspection. My name is Bharat.
My name is Hu Zhang.
And my name is Austin.
Our research paper, we have done our research on this paper of algorithm acceleration regarding expression in deep package inspection. In the contents, we covered introduction, literature review, approach description, comparison, conclusion, and discussion. In this introduction, a regular expression typically represented by the deterministic finite automata, that's called a DFA, and DFA are commonly way to parse regular expression. However, the DFA take a large amount of memory for the patterns, and effective and efficient compression approaches for the regular expression are crucial to save space and improve the throughputs.
Here we compared three algorithms based on these 5 papers. The first approach we will introduce is delayed input DFA, as known as D-squared DFA. The right side of figure 1 shows an alternate type of DFA, which includes unlabeled edges that are referred to as default transitions. When matching an input string, a default transition is used to determine the next state. Whenever the current state has no outgoing edging labeled with the current input characters. We note that the right-hand automata in figure 1 has just 9 edges, while the one on the left has 20. So we can say D-squared DFA generally reduces the number of edges by more than 95%.
Third, the approach's description of CD to DFA means context address delay input DFA. In this algorithm, it helps us to make a selection information available earlier state travel processing, which make it avoid unnecessary memory access and used to obtain automata for very compact can achieve high throughput. In this figure, you have seen the 3-state RUV. First, the R, which is heavy weighted edge, the figure represented by the default transaction. U has label for the characters C and D. State V, which is labeled transaction for the character of A and B, and the arrow coming with the left represent the transaction from other state to the state with RUV. The contents label for the transaction entire state for U is CDR, and the label tells us that the state of U has the outgoing transaction labeled by the characteristic of C and D, that parents of R, which root of default transaction. This tells us that the state V has outgoing transaction labeled with the characteristics of A and B, that is its parent's transaction. I'll pass to my friend Austin.
The concept of a 2N DFA is to improve the DDFA by taking advantage of the fact that every DFA has an initial state. And so we can define a new term called depth as the minimum number of states visited when moving from S to V in the DFA. Because of this, they made a lemma that states, if none of the default transitions in a DDFA lead from a state with a depth P to a state with a depth K, with K greater than or equal to P, then any string of length N will require at most 2N state traversals to be processed. And so basically 2N DFA's default transitions only go backwards. This implies that if a state with a depth of K is visited at some point, then at least K labeled transitions must have been taken. Backwards labeled transitions contribute to make the average case better than the worst case. And I will pass it to Xiaohu.
In comparison section, first of all, we compare the number of transitions before BAR and after AR. Here, from table 1, we can see that 2N DFA has a higher compression rate. In the second table is the comparison between number of transitions with the 2N DFA and D squared DFA. We can see the number of D squared FA is twice than that of original DFA. 2N DFA has the highest transition number. In tab 3, the results show that the memory requirement of 2NDFA is better than that of CD2DFA. In conclusion part, we conclude that the D2DFA required less memory but sacrificed throughput. CD2DFA achieves a higher throughput than uncompressed DFA due to their small memory footprint and higher cache hit rate. 2NDFA achieves a comparable levels of compression with lower probable bounds on memory bandwidth. In contrast with related work, the 2NDFA algorithm can be used also in scenarios where a DFA needs to be built dynamically or updated often. That's our presentation. Thanks for watching.